Hello, this is Dr. Hanaa Assil, and this is about atomic structure. So let us look at what an atom looks like, and you should know that the atom is the basic unit of any substance. So all substances are made up of atoms. Atoms are made up of a central part called the nucleus, and the nucleus contains two types of particles which we refer to as subatomic particles. So when he says subatomic particles, he means the particles inside the atom. What do we have inside the atom? We have protons and neutrons in the nucleus, and these two make up what we call nucleons. So nucleons are everything inside the nucleus. So they are protons and neutrons. And we also have particles that are negatively charged, revolving around the nucleus in specific pathways, which we call energy levels. These are electrons. So the electrons revolve around the nucleus in energy levels or shells. Inside the nucleus, we have protons and neutrons. Now, if we look at these subatomic particles, if we're talking about masses, we say that the mass of a neutron is 1. The mass of a proton is the same as that of a neutron, so we also give it a mass of 1. Now the electron that is revolving in energy levels around the nucleus, this is a very, very small particle with a very, very small mass. So we say its mass is 1 over 1840. 1 over 1840 is a very small number. It's 0.00 something. So that's the smallest particle in the atom. If we're talking about charges, what is the charge on a neutron? We say there is no charge on the neutron. So we say the neutron is neutral. Are we paying attention to the spelling of all of this? So we said inside the nucleus, we have something called neutron. The neutron is neutral. It doesn't have any charge. And protons and neutrons together, we said they make up what? Both of them are referred to as nucleons. Now, what is the charge on the proton? The proton has a charge of +1, and the electron is negatively charged, so we say it has a charge of -1. So if we have a question like this, if he says which of these particles is the one with the smallest mass, the particles with the smallest mass are electrons. The particles with a negative charge are also electrons. The two types of particles in the nucleus of an atom. What is inside the nucleus of the atom? Protons and neutrons. What about this question? Which statements comparing properties of electrons, neutrons, and protons are correct? Neutrons and protons are both heavier than electrons? Yes, we said neutrons and protons are given a mass of 1 each, but electrons are given a very, very small mass. So yes, they are heavier. So my answer is A or B. Now, only electrons and neutrons are charged. Which of these are charged? We said electrons are charged. They have a negative charge. But the neutrons, we said, are neutral. They are 0 charge. So they are not charged. So my answer is the second one, which is B. Okay, what if he says complete the table to show the relative mass and relative charge of a proton, neutron, and electron? So what was the mass of a proton? Mass was 1. Mass of a neutron? 1. What was the charge on a neutron? We said the neutron is neutral, so the charge is 0. What about the charge on the electron? It's -1. Okay, and then if we look at the periodic table, you will have two numbers. One of them is a small number. The small number is referred to as the atomic number. So if we say what is meant by atomic number, we say it is the number of protons. Actually, usually, if this is an atom that has not lost or gained anything, then the number of protons is equal to the number of electrons. So the small number, which is referred to as the atomic number, and please note that this number may be written on top or below. So don't say it's the number on top or it's the number below. It is the smaller of the two numbers. That is the atomic number. If we're defining what is atomic number, it's the number of protons. And then if we're talking about an atom and we're saying, okay, what is the number of electrons? It is the same as the number of protons. So if the atom has equal number of protons and electrons, and protons had which charge? Protons were positive, electrons negative. So overall we say atoms are neutral. Why is an atom neutral? Because it has equal number of positive protons and negative electrons. So overall, the atom is neutral. Now, the other number, which is the bigger number, is referred to as mass number or nucleon number. This is the number of particles inside the nucleus, and we said that is protons and neutrons. So the definition of mass number is it is the total number of protons and neutrons in the nucleus. That means the big number, mass number, is proton plus neutron. The small number is the number of protons. So if I want to get number of neutrons, it is just the difference between the two numbers. So number of neutrons in an atom is the mass number minus the atomic number. So if I say give the symbol of the element that has an atomic number of 14, of course in the exam you will have in front of you a copy of the periodic table. So he wants the symbol. First of all, if he's saying give the symbol, that means you need to give the symbol, not the name, of the element that has atomic number 14. Which one has atomic number 14? We said the atomic number is which one? It's the smaller number. So the atomic number, which element has the smaller number 14? If you look at it, that is silicon. Now give the symbol of the element that has a relative atomic mass of 14. So the one that has a mass number of 14. Which one has a mass number of 14? The big number 14, so that is nitrogen. Okay, this question says the diagram represents an atom of an element. What is the particle labeled X? Of course, X is labeling something inside the nucleus that is positively charged, and that is a proton. What is the mass number of this atom? How do we know the mass number of this atom? Well, we said mass number is the total of protons plus neutrons. That means the total of everything inside the nucleus. So if you count inside the nucleus, I have 4 positives and 5 that are neutral. So my total is 9. That is the mass number of this atom. Everything inside the nucleus, in the middle of the atom. Okay, this question says the diagram represents an atom. The diagram shows that there are equal numbers of A and C. So, what is C? If I say what is C? C is the particle revolving around the nucleus, so C is the electron. So what would be A? If A has the same number as C, we said the number of electrons is equal to the number of what? Of protons. So A is a proton, and that means the other one inside the nucleus must be the neutron. Okay, then we know how to arrange the electrons around the nucleus. The arrangement of electrons around the nucleus is called the electron configuration. So if I look at aluminium in the periodic table, I find that the small number is 13. That tells me that I have 13 electrons. How are we distributing 13 electrons around the nucleus? You should remember that the electrons are revolving around the nucleus in energy levels. The first energy level that is closer to the nucleus, the one inside nearer to the nucleus, takes only 2 electrons. So when we're distributing electrons, the first shell takes 2. Now, the second and the third, we're going to say they take up to 8. So I have a total of 13. I put 2 in the first shell, and then I can put only 8, a total of 8 in the second one. I still have 3 more. I put them into the next shell. So if he says draw the electron configuration, this is how you draw it with circles around the nucleus. But if he says write the electron configuration, we just write it 2, 8, 3. So if I'm trying to distribute the electrons of potassium, I look at the periodic table and I find that the small number is 19. That means I'm supposed to distribute 19 electrons. So how am I going to distribute them? The first shell takes 2, and the second shell can take only up to 8. I still have some more. I put in the next shell 8. That is a total of 18. I still have 1 more, so I put that into the outermost shell, the 4th shell. So if I'm supposed to draw it, notice that I represent electrons either by dots or by X's. So if we draw it, this is how we draw it. If he says write, we're going to write it like this. So the first shell took 2, and then 8, and then 8, and then 1. So this is how we write the electron configuration. So if he says use the periodic table to help you to complete the diagram to show the arrangement of electrons in a chlorine atom, so the first thing you do will be to go to the periodic table. You'll find that chlorine has an atomic number of 17, not the 35. 17 is the number of electrons. So I'm going to distribute 17 electrons, 2 in the first shell, 8 in the next one, and I'm left with 7, so I put them in the outermost shell. Okay, you should also know that an atom may lose or gain electrons. Remember, in our syllabus, the atom does not lose or gain anything except electrons. So what if we said, remember, originally the atom has equal number of protons and electrons. What if an atom loses electrons? So if we have sodium, for example, sodium has 1 electron in its outermost shell. This is an atom. Now, if it should lose that outermost electron, then it will become an ion. So as an atom, what does it have? As an atom, sodium atomic number is 11. That means it has 11 positive protons and 11 negative electrons. So if the number of positives and negatives are the same, then the sodium atom is neutral. But if it should lose 1 electron, that means it has become an ion. Now what has happened? It still has 11 protons. We never lose protons. We lose only electrons. So if the atom has lost 1 electron, that means it has now 11 positive protons, but only 10 negative electrons, and that means it has 1 extra positive charge. So it becomes a positively charged ion, which we call a cation. What if the atom gains electrons? So remember that metals will lose, but non-metals would gain electrons. So fluorine, for example, is a non-metal. Fluorine has atomic number 9. That means it has 9 positive protons and 9 negative electrons. So overall, the fluorine atom is neutral. But what if the fluorine atom gains an extra electron? That means the number of protons is 9, but now the number of electrons is how many? It's 10. So I have 1 extra electron which is negatively charged. That means the fluorine has an extra negative charge. It becomes a negatively charged ion, which we refer to as an anion. So if we have fluorine, we said fluorine has an atomic number of 9, mass number 19. That means it has how many neutrons? We said we get neutrons. How do we calculate the number of neutrons? We said that is the mass number minus the atomic number, the big number minus the small number. That means I have 10 neutrons. How many protons? Protons is equal to the atomic number, which is the small number. This is also equal to the number of electrons. Now, how do we distribute 9 electrons? We said the first shell takes 2. I'm left with 7. I'm going to put it into the next shell. Okay, what if I have F minus? We said, what does F minus mean? The fluorine still has 19 and 9. So fluorine has mass number 19, atomic number 9. But now it's not a fluorine atom, it's a fluoride ion with 1 negative charge. So what is the number of neutrons? It's still the same. Number of protons, still the same. But having 1 negative charge on the fluorine means I have an extra electron, and that means instead of 9 electrons, I have 10. Now, how am I going to distribute the 10? The first shell takes 2, and I'm left with 8 in the second shell. Okay, talking about aluminium. Aluminium has a mass number of 27 and a mass number, atomic number of 13. So how many neutrons? We said neutrons is 27 minus 13, so that's 14. How many protons? Protons is the small number, the atomic number. And that is the same as the electrons. How do we distribute 13 electrons? We said the first shell takes 2. The second shell can take up to 8, but I still have 3 more. I put it into the third shell. What if I'm saying I don't have aluminium, I have aluminium 3+. This is a positively charged ion. The numbers are the same, mass number 27, atomic number 13, but now I have a charge of 3+. So how many neutrons? The 3+ does not affect the number of neutrons or the number of protons, because 3+ means what? 3+ means it has an extra 3 positive charges or extra 3 protons. That means it has lost 3 of its electrons. And that means instead of having 13, I now have 10 electrons. How do we distribute them? 2 in the first shell, 8 in the second. Do we understand what's going on? Okay. Which statement describes positive ions? Which of these is correct? If something is positive, that means it has more what? That means it has more protons than electrons. Remember, as an atom, number of protons is equal to number of electrons. Now, the atom can lose or gain electrons. So if it is positive, that doesn't mean it has gained a proton. No, it means it has lost an electron, and that means the number of protons are now more than the number of electrons. Okay, we have 4 particles, A, B, C, D. Complete the table. He has number of protons, number of electrons, number of neutrons. Nucleon number. We said, what is nucleon number? Nucleon number is the same as mass number, which is protons plus neutron. So remember, nucleon number is proton plus neutron. Okay, so he already did A for me. Let's do B. We want the nucleon number, and we said nucleon number is protons plus neutrons. So that means 11 plus 12. That means I have 23 as my nucleon number or my mass number. What is the symbol of this species or this particle? How do I know which element do I have? This is determined by number of protons. The number of protons determines the kind of element that I have. So if I look at the number of protons, particle B has 11 protons. That means its atomic number is 11. So I look at the periodic table, which one has atomic number 11? I find that it is sodium. Now, why did I put a positive charge on my symbol? Because if it is sodium, it's supposed to have 11 protons and 11 electrons. But he's saying it has only 10. That means it has lost 1 of its electrons, and that means it has an extra positive charge. Are we following? Again, let's take a look at particle C. He is saying number of protons is 8. And he wrote at the end of that line, he wrote O2 minus. What do we mean by O2 minus? O2 minus means the oxygen has gained 2 electrons. It has 2 extra electrons. So instead of having 8, it has how many electrons? It has 10 now. And that means the atom is a negatively charged particle. Now, what is the nucleon number? We said, how do I get nucleon number? Nucleon number is the same as mass number. So it's the number of protons plus neutrons. 8 plus 8 is 16. Now, particle D, he says it should be aluminium 3+. Aluminium, I look at the periodic table. What is the atomic number of aluminium? I find that the small number for aluminium is 13, so that is the number of protons. What is the number of neutrons? Well, looking at the nucleon number. Can you see what the nucleon number is? We said the nucleon number, if he says it's 28, this is the number of protons plus neutrons. And remember, the nucleon number or mass number may be different from the one you have in your periodic table. So you don't use the one in your periodic table, use the one he gives you. So he's saying, I'm talking about aluminium that has a nucleon number or a mass number of 28. That means protons plus neutrons is equal to 28. So if I have 13 protons, I have how many neutrons? 28 minus 13. Are we following how to get all of this? Okay, let's try this one. He says I have sodium 11 and 23. So that means 11 protons, 11 electrons. What is the number of neutrons? Number of neutrons, we get it from the number of nucleons or the mass number. The mass number is 23. That is protons plus neutrons. So if protons are 11, then the number of neutrons is the 23 minus 11, so that is 12. What if we're talking about chlorine as a negative ion? So this is a chloride ion. The numbers are 17 and 37. So what's the number of protons? The number of protons is the atomic number or the small number, so we have 17 protons. How many electrons? As an atom, proton should be equal to electron. But this is something that has negative charge, so it has an extra electron. So instead of 17, it now has 18 electrons. What is the number of nucleons? The number of nucleons is the mass number or the big number, or protons plus neutrons, so that is 37. What about this last one? He's saying I have something that has 26 protons, and we said the number of protons is what identifies the element. So what has 26 protons in the periodic table? That means which one has a small number 26. So if you look at the periodic table, the Fe in the middle of the periodic table is the one that has atomic number 26. So that means we're talking about Fe. But is it Fe plus or Fe minus? Well, he's saying it has 24 electrons. Well, it's supposed to be proton equal electrons. But if I have less electrons, that means I have what kind of ion? I have a positive ion. How many positives? 2 positives, because obviously I have lost 2 electrons, and that means I have 2 extra positive charges. Remember, we're not gaining protons, we're losing electrons. Okay, what's an isotope? Isotopes are atoms of the same element, having the same number of protons, but different number of neutrons. So they will have the same proton number or atomic number, but different mass number. So for example, hydrogen has 3 isotopes. So all of them are atoms of hydrogen. So they are atoms of the same element, having the same what? Same number of protons. All of them have atomic number 1. Remember, we said the atomic number is something that identifies the element. So All of them have one proton and one electron. But they differ in what? They differ in the mass number. That is because they will have different number of neutrons. Remember, number of neutrons is the big one minus the small one. So that first isotope has no neutrons, and this is the only element in your periodic table that does not have any neutrons. Now, the isotope that has a mass number of 2, that means 2 minus 1, so it has 1 neutron. The isotope that has a mass number of 3, so that's 3 minus 1, so it has 2 neutrons. So which row describes isotopes of the same element? We said isotopes will have the same what? The same number of protons, different number of neutrons. Which of the following is a pair of isotopes? So, let's remember, what does isotopes mean? First of all, they are atoms of the same element. So I can't say carbon and nitrogen are isotopes. But also my second choice here says sulfur and sulfur 2 minus. And these are two things that have same number of protons, same number of neutrons. They have the same mass number. Isotopes should have different mass numbers. So this S2 minus is just the ion after the sulfur has gained 2 electrons. What about O2 and O3? Well, O2 is called oxygen, O3 is called ozone. So these are two different elements. What about my last choice? They are atoms of the same element, so both of them are lead. Lead is Pb. They have the same atomic number, so both of them have atomic number 82, but different mass numbers, so these are isotopes. Hydrogen has 3 isotopes. State in terms of subatomic particles. Again, we said subatomic particles means the particles inside the atom. So protons, neutrons, electrons, these are called subatomic particles. State one way in which these isotopes are the same and one way in which they're different. So we said hydrogen isotopes have the same number of protons but different number of neutrons. The symbols for 2 isotopes of iron are shown. How do these 2 isotopes differ in their atomic structure? What is the difference between these 2 isotopes? They have different what? They have different number of neutrons. Determine the number of neutrons present in one atom of this isotope. We said, how do we get number of neutrons? The big number minus the small number. So 57 minus 26, that is 31. Determine the number of electrons in Fe3+. Now, Fe has an atomic number of 26. That means originally it has 26 electrons. What if I'm telling you I'm talking about Fe3+? What does 3 plus mean? It means it has lost 3 of its electrons. And that means instead of 26 electrons, it now has 23 electrons. What about this one? We have 2 isotopes of calcium. Complete the table to show the number of protons, neutrons, electrons in each of them. Of course, if both of them are isotopes of calcium, that means their atomic number is 20. And that means, so number of protons for each of them is the same, 20. Number of neutrons, we said the number of neutrons is the big number minus the small number. So this one has 23 neutrons. The other one, 48 minus 20, that is 28 neutrons. What about the number of electrons? These are atoms, so protons are equal to electrons. What if he says determine the number of electrons in one calcium ion? So I have calcium 2+. What does that mean? It means that the calcium has lost 2 of its electrons. So instead of having 20, it now has 18 electrons. Okay, what about this one? Use numbers from the box to complete the table. This diagram that we have, what is the atomic number of the atom? How do we know atomic number? atomic number is the number of protons. How do we know which one is protons? He gives me a key that says that the white balls are protons. And even if he doesn't give me the key, I should know that the protons are equal to the number of electrons revolving around it. So if I have 3 electrons, that means I must have 3 protons. So that's the atomic number. What is the number of shells? How many shells do we have? Well, we have 2 shells that are shown. What is the mass number of the atom? How do I get mass number? We said the mass number is number of protons plus neutrons, so the number of everything inside the nucleus. I have 4 neutrons and 3 protons, so my mass number is 7. Then he's saying what's the number of protons in an isotope of this element. We said isotopes would have the same number of protons. So if this one has 3 protons, then the isotope would also have 3 protons. What is the meaning of a relative atomic mass? The relative atomic mass is basically the mass number that we have in the periodic table. And this is actually an average of the mass number of the different isotopes in the ratio of their occurrence in nature relative to the mass of an atom of carbon-12. So remember, all the mass numbers that we have are relative to what? They are relative to carbon-12, and the mass numbers that we have are an average of the mass numbers of the different isotopes. So for example, if I tell you that chlorine has 2 main isotopes, one type of the chlorine atoms has mass number 35, the other one has mass number 37. Now, if I have a total number of atoms of chlorine, 75% would have a mass of 35 and 25% would have a mass of 37. So what is the average of all of this? Now, to get the average, we do the mass number of one times its abundance plus the mass number of the other times its abundance divided by 100. So the average atomic mass of a chlorine atom is 35.5, and that is what you have in your periodic table. So when you look at the periodic table, the mass number of chlorine is 35.5 because it is the average of the isotopes taking into account the occurrence of each of them in nature. This is another question. He gives you the isotopes and their percentage, and you're required to calculate the relative atomic mass of silicon. So again, we said, how do we do that? The first isotope has a mass of 28. So 28 times its percentage plus 29 times its percentage plus 30 times its percentage divided by 100. Now this comes out in your calculator, it comes out 28.109. But he's saying give your answer to what? He's saying give your answer to 1 decimal place. So my answer has to be 28.1. Please notice if he's telling you to give your answer in a specific way. Another example, he's given me 2 isotopes of bromine. One of them has a mass number of 79, the other has a mass number of 81. And he's saying calculate the relative atomic mass. Again, how do we do it? The mass number of the first one times its abundance plus the mass number of the other one times its abundance divided by 100. Now this comes out to be 79.944. Now he's saying give your answer to what? He's saying give your answer to 3 significant figures. What does that mean? What should be my answer? 3 significant figures means I need a total of 3 numbers. So 79.9. You cannot leave it 0.944. It is 79.9. This is what he's looking for. Okay, another example. He says I have 7.6 of this and 92.4% of this. Calculate the relative atomic mass of lithium. Again, which one am I going to use, the 6 or the 3 on lithium? Remember, we're using the mass number, so it's the big number. So the first one has a mass number of 6 times its abundance, plus the other one has a mass number of 7 times its abundance over 100. This gives me 6.924. Is that my answer? No, he's saying give your answer to 2 decimal places. What does 2 decimal places mean? It means 2 numbers after the decimal. So this is my answer, 6.92. You cannot leave it 6.924. You lose a mark. Okay, and that's the end of this. I hope this was useful. Thank you very much and keep listening to the videos. Thank you.